Lesson 6.4, Polar Coordinates. Everything you've done so far in mathematics, we've talked about the rectangular coordinate system, your Cartesian plane, okay, the basic x and y axis where you've graphed and plotted points. Now we're going to learn a different coordinate system so that we can graph and plot points for more complicated functions. For example, if we had 10 cosine of 4 theta, if we want to graph this using the polar coordinate system, we get a very complicated looking function. It looks like a bunch of flower petals. Okay, so we're going to be learning the basics of this other coordinate system, converting between the rectangular coordinate system and the polar coordinates. Okay, these concepts are used most often in calculus, so those of you that plan on going into engineering or something like that will have to go more in depth with this coordinate system. Some of the basic ideas of the polar coordinate system: we have what's called the polar axis, which is the starting point of our angle theta. The polar axis is basically like the positive x-axis. We have point O, which we can think of as the origin on the regular rectangular system. We have point P, which has a distance r, and we have obviously our theta value. Okay, the distance from O to P, this segment, that's referred to as the pole. Okay, so we have our initial side where theta is starting, we have our terminal side, we get our angle theta, the distance from O to P referred to as r. So first thing we're going to go through is how to plot the points with given polar coordinates. So in part A, we have point P, which is 2, pi over 3. So 2 refers to the distance from point O. Pi over 3 refers to our theta angle. So if we're starting across the bottom on our x-axis, which is our polar axis, we're going to open up until we get to pi over 3. So we know we're going to have this segment. So if we go a distance from O, a distance of 2, we get to point P. So this is point P, has a theta value of pi over 3 and a distance of 2. If we look at part B, trying to plot point Q, we have a distance of -1 and 3 pi over 4 is our theta value. Okay, technically, no, we can't have a distance of -1. So that negative just tells us we're going to go in the opposite direction from which we did in the last problem. So first thing, we're starting with our polar axis. We're going to open up with an angle of 3 pi over 4, which gives us this segment. So starting at point O, we're going to go in the negative directions. We're going to go down a distance of 1. So we have a distance of 1. Our theta value opened up to 3 pi over 4. So we have point Q. In C, we have point R. We have our R value of 3, -45 degrees for our theta value. So starting at our polar axis, negative, we have to go clockwise now. So we go clockwise, -45 degrees. From O, we have to go a distance of 3, and we would get to point R. So that's how you plot with polar coordinates. The first value tells you the distance. The second value tells us your angle in theta. The main portion we're going to focus on in this lesson is how to convert from rectangular coordinates to polar coordinates, or vice versa. So below we have 4 different equations we're going to use in order to perform those conversions. So if we let the point P have polar coordinates r, theta, and rectangular coordinates x, y, then these following equations have to be true. X is equal to r times the cosine of theta, y is equal to r times the sine of theta, r squared equals x squared plus y squared, and tangent theta is equal to y over x. So I would write down these 4 equations. Make sure you have those in your notes, because we're going to use all of these when performing these conversions. In the next example, we're going to find the rectangular coordinates of the point with the polar coordinates 2, 7 pi over 6. Okay, so right now this is in polar coordinates. We want to convert it into something that we recognize. So first thing we're going to have to do is write down the equations we need to use. First one, x equals r times the cosine of theta. And then we're going to have to use y equals r times the sine of theta. Okay, we know what our r value is, it's 2. We know our theta value is 7 pi over 6. So if we substitute those values in, x is equal to 2 times the cosine of 7 pi over 6, which if you use your unit circle, cosine of 7 pi over 6 is negative radical 3 over 2. So x is equal to 2 times negative radical 3 over 2. The 2's will cancel each other out, so our x coordinate is going to be negative radical 3. Similar process for y. Substitute in what we know, 2 times the sine of 7 pi over 6. So y is equal to 2 times the sine of 7 pi over 6 is equal to negative 1/2. So this is times negative 1 over 2. So if we multiply that out, we get y equals negative 1. So our rectangular coordinates would be negative radical 3 for our x value, negative 1 for our y value. In the last example, we're going to find two polar coordinate pairs for the point with the rectangular coordinates of 1, negative 1. So if we just want to think about where this point would be to give us a reference, if we went over 1 and down 1, our point would be somewhere in this location. Okay? So the two formulas we're going to have to use in this case are r squared equal to x squared plus y squared, and tangent theta equal to y over x. Okay, so if we look for our first equation, r squared equals x squared plus y squared, plug in the values we have for x and y. R squared is equal to 1 squared plus negative 1 squared. So r squared is equal to 2. So if we take the square root of each side, we would get r is equal to plus or minus radical 2. Now we need to find that theta value. So we know the tangent of theta is equal to negative 1 divided by 1 would be negative 1. To get theta by itself, we would take the inverse tangent of each side. So theta is equal to the inverse tangent of negative 1. Using your unit circle, that would be a theta value of negative pi over 4. Okay, remember we got to use domain and range concepts of the inverse tangent function. So now we need to find the two polar coordinates that align with 1, negative 1. So if we would start with our polar axis and open up to negative pi over 4, we would get to a segment that goes through the point we already plotted as a reference. Okay, not perfect, but you get the idea. So if we go negative pi over 4 and then a distance of radical 2, we would get to that point. So one of our ordered pairs, our polar coordinates, is going to be radical 2 and negative pi over 4. To get to that same point, if we started on our polar axis and open counterclockwise, that would be 3 pi over 4. That would get us to that same segment. Now, since we opened counterclockwise, we would have to go a distance starting at the origin, negative radical 2. So the second polar coordinate would be negative radical 2 and 3 pi over 4. So our rectangular coordinate we started with was 1, negative 1. The two polar coordinates that could be created and reach that same point would be radical 2, comma, negative pi over 4, and negative radical 2, comma, 3 pi over 4.